In your lesson today, you're going to have a review of exponents and order of operations. And we're going to start off with talking about exponents. Exponential notation is a shortcut way to write multiplication of the same number. It's like repeated multiplication. Okay, and there are a few different ways that we can show certain exponents. Like this example, the number, whatever x happens to be, is being raised to the power of 2. When you have a power of 2, that's read as x to the second power, or x squared. If you ever hear someone saying a number squared, they mean that it has an exponent of 2. Same thing with this example down here. Anything with an exponent of 3 is read as x to the third power, or x cubed. Okay, so if they cube a number, they're going to raise that number to the third power. X to the fourth power, well, that's exactly how you read that. A number, an exponent of 4 is read as x to the fourth power. Okay, and so in any exponential notation, there are two different parts. In this case, we have this 5 and this 3. The 5 is called the base. Okay, the number that is being raised to the exponent is called the base. The 3 is the exponent. Okay, the 3 is the exponent. The exponent tells you how many times to use the base as a factor. Okay, so again, the base is the number or expression that's used as a factor in repeated multiplication. The exponent tells you how many times to use the base as a factor. And so in our little oval shape down here, it says to write in exponential form or as a power, the first thing you have to do is count how many times the base is used as a factor. So in this example down here, I see it's the number 4 being repeatedly multiplied. 1, 2, 3, 4, 5 copies of the number 4. So what I'm going to do is write down the base number. The base number is the 4. It's the number being used in the repeated multiplication. And then I'm going to use the exponent. The exponent was how many times I used it. Well, I just counted up 5 copies of the number 4. So I would rewrite this multiplication as 4 to the 5th power. Okay, so applying that to our first example down here, 8 times 8 times 8 is the same number multiplying itself 3 times. In exponential notation, we would write this as 8 to the third power, or 8 cubed. All right, again, with an exponent of 3, we can call that cubed. The base is the number 8. It's the number that's being used as a factor in repeated multiplication. The exponent is 3 because that's how many times we multiplied 8 by itself. And the product, or the answer, is what we get when we actually do that multiplication. Well, we have 8 times 8 times 8. 8 times 8 is going to give us 64, and so we just have to do 64 times 8, which is going to give us a final answer of 512. Okay, the product of 8 to the third power is 512. In the next section, we're going to look at exponents when the base is a negative number. In this case, we've got a base of -1. And I'm going to take -1 and I'm going to raise it to the first power. Well, that's just the number -1 by itself. Okay, one copy of the number -1 is equal to -1. Okay, in this example, I'm going to take -1 and I'm going to raise it to the second power, or square it. That means to take -1 and multiply it by itself. So I'm going to do -1 times -1. Well, I know that a negative times a negative is a positive number, and 1 times 1 is 1, so this must be equal to +1. In this example, I have -1 to the third power, or -1 cubed. That means to do -1 times -1 times -1. Okay? And so if we were to evaluate this, well, we just said over here that -1 times -1, this is equal to 1. And so this is 1 times -1. Well, that's going to have to equal -1 as well. Positive times a negative would give us a negative answer again. -1 to the fourth power is -1 times -1 times -1 times -1. Okay, and if we think about what we just did here, -1 times -1 times -1, okay, that I see right here, that was equal to -1. So this portion is equal to -1. So this is really just -1 times -1, which will get me back to, again, a +1. And maybe you're starting to notice a little pattern happening here. In this example, -1 to the 5th power, I'm going to do -1 times -1 times -1 times -1 times -1. Okay, well, -1 to the 4th power right here, -1, -1, -1, -1 there, that was equal to a +1. So this is 1 times negative 1, which will again get me back to a negative 1. Okay, and so hopefully you're starting to notice a little bit of a pattern here. If I've got my negative base, okay, and the base was negative in all of these, and my exponent was an odd number, okay, well that gave me a negative answer, or a negative product. A negative base, this is our first rule, a negative base raised to an odd exponent. Okay, a negative base raised to an odd exponent gives a negative product. Okay, if you have a negative base and an odd exponent, then you know the answer will be a negative number. If we have a negative base with an even exponent, like in these two examples, okay, our exponent was even, well then that gave us a positive answer, and so that's going to be our second rule. If we have a negative base, and this time it's going to be raised to an even exponent, well, this gives a positive product. Okay, and so it should be easy for us to identify if we have a negative base, if our answer is going to be positive or negative, by looking at the exponent. Again, if it's an even exponent, we'll have a positive product. If we have an odd exponent, then that's going to give us a negative exponent. Now, what happens if we have an exponent of 0? Well, we can show what's going to happen here if we start to look at some patterns. I'm going to start with a base of 3. 3 to the third power, well, that's going to mean to do 3 times 3 times 3. Okay, and if I were to evaluate that, 3 times 3 is 9. 9 times 3 is 27. Okay, 27. In the 3 squared example, well, that's just 3 times 3, and that's going to give me an answer of 9. 3 to the first power, well, that's just equal to 1 copy of 3, so that has a value of 3 itself. Okay, and so if you notice what's happening here, every time my exponent goes down by 1, I lose 1 copy of 3 that I'm multiplying. So really what's happening to my answer, every time I decrease the exponent, well, I'm taking my previous answer and I'm dividing it by 3. 27 divided by 3 is 9. I decrease the exponent again. I take my previous answer, 9, divide it by 3, and that gives me an answer of 3. Okay, so what's going to happen with this example of 3's raised to the 0 power? Well, you can't really expand something raised to the 0 power, but you can evaluate it just by following this pattern here. I took my previous answer, divided by 3, and got 9. I took 9, my previous answer, divided by 3, and got 3. So now I'm going to take this answer, my previous answer of 3, and I'm going to divide it by 3 again. 3 divided by 3 is equal to 1. Okay, so 3 to the 0 power is going to have a value of 1. Well, what happens when our base is going to be 2 in this case? Well, 2 to the third is equal to 2 times 2 times 2. And that has a value, 2 times 2 is 4, 4 times 2 is 8. 2 squared is 2 times 2, which equals 4. 2 to the first power is just 2. So notice this time, every time I'm decreasing my exponent by 1, I'm losing a factor of 2. So I'm really taking my previous answer and I'm dividing it by 2 to get to the next answer. 8 divided by 2 is 4. 4 divided by 2 is 2. And so I'm going to keep this pattern going. Okay, 2 to the 0 power, well again, I can't really expand it, but if I follow this pattern, take the previous answer, which was 2, divide it by 2, 2 divided by 2 equals 1. So 3 to the 0 power equals 1, 2 to the 0 power equals 1, and in fact, any base with a power of 0 is going to be equal to 1. So if you look at your base and you notice that the exponent of 0, you already know that the answer is going to be 1. In the next section, we're going to look at order of operations, and we need to recall what those order of operations are. You may remember something called PEMDAS, okay? And I'm going to be writing this just a little bit differently from what you learned with PEMDAS. The first thing is that we have to look for, you might be thinking P for parentheses, but I like to call these things grouping symbols. Grouping symbols are the first things that you need to look for. Okay, grouping symbols could be parentheses, which you're used to, But they could also be brackets. Brackets look like these squared parentheses, something like that. They could be braces. Braces are these little squiggly lines that are so much fun to draw. Or they could even be absolute value bars. Absolute value bars are another form of grouping. If there's anything, any operation inside of the absolute value bars or inside of any of these grouping symbols, that's the first thing that you need to evaluate. After you take care of your grouping symbols, then you're going to look for any exponents that you need to evaluate. Okay, so look for exponents after your grouping symbols. Next thing that we're going to look for is multiplication or division. Multiplication or division in order from left to right. Left to right. Okay, when we are doing this level, we're looking for multiplication or division in order from left to right. We read an equation just like we read a sentence in a book from left to right. So, if the multiplication is first, then do the multiplication. But if the division comes first, then you're going to do the division first. The last thing we need to look for is addition or subtraction. Addition or subtraction. And again, we're going to have to go in order from left to right. In order from left to right. So in our problem, if the addition comes first, we'll worry about the addition. But if the subtraction comes first, then we're going to take care of the subtraction first. Okay, and so I want to practice a couple of these problems underneath. Number 1, okay, I notice I have subtraction, division, and addition. Well, looking at my list back up above, I see that division is the first thing that I would need to do. And so the first thing I'm going to do here is the 6 divided by the 2. 6 divided by the 2 is 3, so I'm going to have 14 minus 3, and then I'm going to bring down the plus 12. Okay? And now it's just subtraction and addition. They're on the same level, so I'm going to go in order from left to right. 14 minus 3, that gives me 11, and then 11 plus 12, my final answer here is going to be 23. All right, I want to look at numbers 9 and 10 now, because if you look at these, they look very similar, but with one distinct difference. In number 9, my number -4 is written inside of parentheses and then raised to the third power. But in number 10, rather, my -4 isn't in parentheses, and it's just raised to the third power. These mean two different things. If we look at number 9, this says take the number -4 and raise it to the third power, which means I'm going to do -4 times -4 times -4. And now when I evaluate this, -4 times -4, well, that's going to be equal to a positive 16. A negative times a negative is a positive. And now I'm going to multiply that by -4. Okay, well, 16 times 4, that's going to give me 64. A positive times a negative is a negative. And so this is going to give me an answer of -64. In number 10, the meaning of this problem is different, okay? Since it's not the number -4 in parentheses raised to the third power, I'm going to ignore this negative symbol for the time being. This means to do negative of 4 to the third power, which is 4 times 4 times 4. Okay, and so when I evaluate this, I'm going to have negative of, well, 4 times 4 is 16, and 16 times 4, we just said, was 64. Okay, so -16 times 4. Well, 16 times 4, we just said, was 64. And so we have this negative symbol on the outside. And really, if we think about this, this negative symbol is the number -1. -1 that's multiplying whatever I get when I do what's in the parentheses first. So this really means to do -1 times 64, which is going to give me a final answer of -64. So watch out for these examples, okay? The number in parentheses, you're going to multiply that number by itself however many times the exponent tells you to. But with this example, you're going to do -1 times whatever the number is in parentheses here raised to that power. In this case, 4 times 4 times 4. We evaluate that to get 64. This negative symbol is the number -1 that we're going to multiply in order to get our final answer.